Atoms, once thought to be the universe's basic units, were found to consist of subatomic particles like electrons, protons, and neutrons. While the atomic model explains the arrangement, it doesn't address the origin of matter. So, particle physicists started studying the smallest particles and classified them as elementary or composite. But how do we know that a particle is the most basic form of matter? Particle physicists use different techniques to understand and categorize resonances, which are like special patterns or behaviors in the world of tiny particles. They look at things like how particles' masses change and how they move in different directions after certain events. By studying these behaviors, scientists can figure out important details such as their sizes and characteristics. It's a bit like solving a puzzle with various pieces, and each method helps them put together a clear picture of what's happening in the microscopic world of particles. I am Florence Sanchez, and in this study entitled Effects of Background Poles on the Interpretation of F 980, we study this scattering amplitude based on Morgan and Pennington's pole counting argument. The F0 980 resonance is a scalar isoscalar meson observed in a pion-pion invariant mass distribution. It is characterized by its mass of approximately 980 MeV, which is below the kaon-antikaon threshold. Its relatively low mass compared to other scalar mesons made it challenging to analyze using the usual parametrization, and hence we are using a different approach. We simulated the poles using the uniformized S matrix and compared one and two pole configurations. We then added the background poles and studied how it affected the line shapes of both one pole and two pole configurations.